Assalamualaikum and good day everyone. So today we are going to continue the second part of the factors that affect the reaction rate. So let's have a look at the learning outcome. So by now you have covered the part A actually. Okay, you have seen the effect of the following factors towards the reaction rate. Okay, so for today we are going to cover the other learning outcomes. First one is we want to see the effect of temperature on reaction rate by illustrating using the Maxwell-Boltzmann distribution curve. Okay, and then kita akan compare the curve of the energy profile diagram for a reaction with and without catalyst. Okay, and then kita akan tengok pasal Arrhenius equation lah. So daripada Arrhenius equation tu pula nanti kita akan boleh tengok relationship antara rate constant, temperature dengan activation energy. Okay, and then kita akan do some calculation after that by using the Arrhenius equation. Okay, so let's just revise a bit on the factors affecting the rate of chemical reactions. Okay, so basically untuk concentration, temperature and also particle size, dan kita ada pressure dengan catalyst. Okay, so antara 5 ni ada 3 yang directly proportional to the reaction rate. Okay, concentration, temperature, pressure. So 3 ni kalau dia increase, even the reaction rate pun akan increase juga. Meanwhile kalau particle size pula dia dia inversely proportional. The smaller the particle size, the higher the reaction rate. Catalyst pula dia akan dia tak directly affect the reaction rate lah, but what it's going to do is dia akan lower down kan the activation energy. Dia akan bagi alternative pathway. Okay, so bila dia dah lower down kan the activation energy, meaning more molecule can react then. Okay, so bila more molecule can react, meaning the reaction rate akan increase juga after that. Okay, alright, so kita lebih kepada fokus kita hari ni adalah lebih kepada temperature and also catalyst lah. Okay, so kita akan tengok pasal temperature. So kita revise balik pasal temperature. So when temperature increases, so the kinetic energy of molecules also increases. So bila kinetic energy of molecules increase, so what happen next is the energy of collision pun akan increase juga. So bila energy of collision increase, meaning they can overcome the activation energy then. Okay, so since more collision boleh overcome the activation energy, therefore frequency of collision pun kita akan boleh nampak dia akan increasing. So more collision meaning more effective collision. Okay, so hence the rate of reaction will increases. So now kita nak illustrate by using the Maxwell-Boltzmann distribution curve. So apa kegunaan Maxwell-Boltzmann distribution curve ni? This is to actually to compare antara dua temperature. Okay, so what happened to the reaction rate kalau satu at a lower temperature, satu lagi at a higher temperature. Okay, so kat sini the y-axis is the number of molecules, and then kita ada the x-axis kat sini kita ada kinetic energy. So ada dua curve class. Okay, ada dua curves yang kita akan lukis. The first curve dia punya peak is slightly higher. Okay, and then they're slightly going like to the left. Saya tak tahu left mana kamu, left. Okay, so the left side of the graph. Okay, so this is for a low temperature, and then the second curve pula adalah untuk high temperature. Tapi high temperature ni you can see that dia punya peak is slightly lower. Okay, and then dia adalah in terms of peak dia ni adalah to the right side, like sort of to the middle part of the graph itself. Okay, so apa sebenarnya benda ni nak tunjuk? Okay, so kat sini dia ada activation energy lah. Okay, so molecules with enough kinetic energy to react adalah dekat bahagian sebelah ni. Okay, yang melepasi the activation energy. So we can see that most of the molecule kalau dekat low temperature, so basically ini adalah bahagian average lah. So most of the molecule at low temperature has a very low kinetic energy. So kat sini dia punya energy, so very low. Meanwhile, kalau untuk yang high temperature pula, so average most of the molecules dia berada dekat bahagian ni. So they have dia punya energy tu slightly to the right, meaning they have a higher energy. bila dekat higher temperature dan. Okay, so apa kegunaan untuk kita tahu this particular area pula? Okay, so ada beberapa benda yang kamu kena ambil tahu. Okay, so take note sekali lagi, T1 temperature dia is lower than the T2. Okay, so area under the curve represent the total number of molecules in direction, and the total number of the particles under each curve are the same. So basically, kalau bawah yang curve biru ni ada 10 molekul, so bawah curve yang warna merah ni pun ada 10 molekul juga. Okay, so kalau kita perhatikan dekat sini, okay, so only collisions with energy greater than activation energy are able to react because they can overcome the activation energy kan. So diorang boleh react. Okay, so kalau the one that under T1 punya graph, under the blue line, okay, it shows that only few particles have sufficient energy. Sufficient energy meaning equal to or greater than the activation energy, okay, to react at T1. So as you can see, this one here yang warna gelap sikit, this is the number of particles yang boleh overcome the activation energy. Okay, and then bila kita compare kan, the one that under the T2, okay, so at a higher temperature T2, so more particles have sufficient energy to react. So as you can see, untuk yang bawah merah ni, semua ni yang warna gelap ni dengan yang warna yang muda sikit ni, yang tu semua adalah the number of molecules yang able to react under T2. Okay, so this shows that the rate of reaction will increase when the temperature increases. Okay, because we can see that more molecules bawah T2 ni, meaning the rate of reaction akan increase dan. Okay, bila temperature increase. Meanwhile, kalau kita tengok balik T1 ni, yang bawah biru ni, sikit je kan area yang bawah ni. So it shows that fewer molecule are able to react dan. Okay. So kamu kena pandai lukis, okay? You have to know how to illustrate this Maxwell-Boltzmann distribution curve. You have to make sure that ada two curves. So the one that has a higher peak, but to the left side, okay, higher peak to the left side of the graph, okay, that should be for the lower temperature. And then the one that have a lower curve, okay, lower peak, okay, tapi dia punya peak tu slightly to the right ataupun slightly to the middle of the graph, that should be for the higher temperature. Okay, and then make sure you tandakan juga the activation energy. Okay, so kita tengok pasal catalyst pula. So catalyst is a substance that increases the rate of reaction by providing an alternative pathway with a lower activation energy. Okay, so you have to know how to draw the energy profile diagram yang ada both activation energy for the uncatalyzed reaction and also the one with catalyst. Okay, so kena ada dua-dua. So untuk energy profile diagram yang involve catalyst ni, you only have to show the activation energy of forward reaction, so you don't have to show for the reverse reaction. Okay, so as you can see here, the one with the red curve, so this is the to show that the energy pathway untuk yang ada catalyst. Okay, the one with the blue curve, this is to show the energy pathway untuk yang without catalyst. Okay, so as you can see, the activation energy without catalyst is higher, okay, compared to activation energy kalau yang ada catalyst is lower. So bila lower, lagi senanglah molekul nak menghasilkan lagi senang molekul untuk react lah, and in order untuk menghasilkan a new product dan. Okay, so catalyst will not affect the enthalpy of reactant of product, meaning delta H takkan berubah pun. Okay, delta H takkan berubah, dia cuma kacau the activation energy yang forward sahaja. It only decreases the EA. Okay, so the metal surface dekat sini adalah sebagai catalyst sebenarnya. Okay, so kita ada dua reactant kita kat sini, NO dengan CO. So apa yang berlaku adalah bila NO langgar the catalyst, the metal surface, so somehow dia akan cepatkan the process sebab dia bagi alternative pathway kan. So dia akan cepatkan proses untuk yang untuk the reactant to react together and produce a new product. Okay, compared to kalau nak tunggu yang without catalyst, tak ada yang metal surface tu, so they have to collide first and only then mungkin berlaku effective collision, mungkin tak. Okay, tapi with the help of catalyst, okay, so catalyst tu akan bagi alternative way so that the reaction rate akan lagi tinggi. Okay, so when catalyst is added to the reaction, the new alternative pathway with a lower activation energy is produced, so more particles can overcome the new lowered activation energy. Therefore, the number of particles that have higher energy than the activation energy increases, so the frequency of effective collision increases, so the rate of reaction also increases. So untuk yang catalyst ni, selain daripada kamu kena faham apa yang catalyst buat kepada kita punya energy pathway, you also have to know how to draw the energy profile diagram that shows the energy pathway untuk the reaction with catalyst and without catalyst. Okay, so yang ni just nak tunjuk untuk yang kalau kita tunjuk activation energy with catalyst by using the Maxwell-Boltzmann distribution curve. So let's say dekat sini adalah the activation energy, okay, untuk yang without catalyst. Okay, so what will you expect kalau yang the one with ada catalyst then? You know that dia akan lower down kan the activation energy, right? Meaning dia akan going towards to the left side of yang activation energy yang asal lah. Okay, tapi yang ni sebenarnya tak penting sangat untuk kamu tahu yang ni. This is just to show you apa yang berlaku dekat bahagian Maxwell-Boltzmann distribution curve. Okay, untuk kita tunjuk yang EA with catalyst. Okay, tapi yang ni tak penting sangat. Tapi as you can see, kita just discuss ya. As you can see, the area under the curve will be increased. As you can see, lagi banyak molekul yang boleh react kan. Okay, tak kisahlah yang with lower temperature kah, the one with high temperature kah, we can see that more molecule can react that. Okay, so catalysts provide an alternative pathway with lower EA. More particles have sufficient energy to overcome the new lower EA, which is the EA with the catalyst ni lah. Okay, yang ni dia tak tunjuk yang beza temperature tu tadi. Dia masih lagi Maxwell-Boltzmann curve juga ni, tapi dia tunjuk untuk satu temperature je. Okay, so you can read this on your own. Okay, tapi yang penting adalah this part here class. Okay, ini yang penting untuk kamu tahu nak compare activation energy with catalyst ataupun without catalyst. Okay, make sure the one with catalyst lower EA. Okay, yang ni untuk isothermic, yang ni pula untuk endothermic. And as I told you just now, there's no need for you to do the reverse reaction punya activation energy. You only have to do the forward reaction saja. So as you can see, the one yang E prime ni, E prime is the one with catalyst. Okay, so kat sini pun sama, the one yang ada E prime A ni, yang tu adalah untuk yang catalyst punya. Alright, so let's go to the next part, which is Arrhenius equation. Okay, so daripada rate law ataupun rate equation, kita boleh tengok relationship antara rate dengan rate constant dengan concentration. Okay, so we can see that if K increase, meaning rate pun akan increase. If concentration increase, rate pun akan increase. But that is not the case untuk kita punya zero order. Okay, first order, second order reaction, concentration akan affect the rate of reaction. Tapi kalau zero order, tak. Sebab zero order, kita ubahlah macam mana sekalipun the concentration, dia tak akan affect the rate pun, kan? Okay, so the rate equation shows the effect of changing the concentration of reactants on the rate of reaction. Other factors such as temperature and catalyst that also changes the rates of reaction are all included in the rate constant. We cannot see it in the rate equation, tapi sebenarnya K, rate constant tu sendiri sebenarnya mewakili temperature dengan catalyst. Tapi tak boleh nampak kan dalam rate equation ni. Sebab tu nak introduce kat kamu sekarang ni adalah Arrhenius equation. Okay, so in 1889, Svante Arrhenius, I think. Okay, this is the guy. Okay, ni scientist there proposed the following mathematical expression for the effect of temperature on the rate constant. Okay, so K equals to A exponent to the power of EA over RT. Macam tu kan cara sebut dia. Okay, so apa K, apa A, apa E, apa EA, apa RT. Okay, so K is basically the rate constant. Okay, and then A adalah the Arrhenius constant. Dia berkaitan dengan the number of collision, the frequency of the collision. Okay, and then E exponent lah. Okay, and then EA is the activation energy. R is the gas constant, but now kita akan guna gas constant 8.314 joule per mole per Kelvin. So kita tak guna dah yang 0.082 or 62. Okay, do we have to hafal the 8.314 ni? Tak perlu pun. You can always refer balik dekat list of constant. And then T macam biasa, it is the absolute temperature, and make sure the temperature must be in Kelvin. Okay. By the way, the activation energy usually given to you adalah kilojoule per mole kan. Okay, tapi bila kita masukkan dalam Arrhenius equation ni, make sure you change the activation energy into joule. Okay, sebab dekat R ni, gas constant ni guna joule bukan kilojoule. So make sure you convert it daripada kilojoule pergi joule. Okay. So the relationship between the rate constant and T can be seen in the K versus T graph. So you will get an exponent graph. So kamu akan nampak graph curve macam ni, whereby the y-axis is K, the t-axis is the x-axis is temperature. Okay. So as you can see class, ada star dekat sini because there's a bit of slight changes dekat this particular slide. Okay. So from the graph, we can see that as the K increases, the temperature also increase. Ataupun as the temperature increases, the K increases. Okay, so ini yang kita dapat daripada formula K equals to AE exponent EA over RT. But then, it's a bit hard kan untuk baca this particular equation here, and then kita nak pergi cari the gradient, nak tahu gradient dia yang mana sebenarnya. Kan, it's a bit hard. Okay, so hard to get the EA from this graph. So instead of kita guna directly this particular equation here, so apa yang kita akan buat adalah kita ubah sikit. Okay, so kita loankan both side. Okay, daripada graph ni kita loankan both sides. Sini sebenarnya ada equal sign kat sini. Okay, so bila kita loankan both side, so ni sepatutnya, kenapa hilang semua ni? So ni sepatutnya ln A plus kan? Ln A plus ln E. Ini ada negative sign sepatutnya, sini ada negative sign, ini ada negative sign. Okay, so kita akan dapat ln K equals to negative EART ln E plus ln A. Okay, and then bila ln E is equals to 1, so substitute masuk, therefore kita akan dapat ln K equals to negative EA over R dalam kurungan 1 over T plus ln A. Okay, so see the linear relationship. Okay, whereby the ln K tu sebenarnya dia ada jarak ln dengan K. Okay, so itu adalah Y. Okay, meanwhile negative EA over R, that is the M. Okay, and then 1 over T pula, that is the x-axis, and then ln A pula adalah the C, the intercept. Okay, so kalau daripada equation ni, okay, so ini equation yang penting lah. Equation yang bawah ni yang penting sebenarnya untuk kamu kena ingat. Okay, so from the equation ln K equals to ln A minus EA over RT. Okay, ataupun kalau nak tulis macam ni pun boleh juga. Kalau nak tulis yang macam tadi, yang dekat slide sebelah tadi adalah macam mana dia tulis, ln K equals to negative EA over R 1 over T plus ln A, mana-mana aja. Okay, sama aja sebenarnya. It's just the way kita susunkan balik the equation. Okay, so what we can see here is when temperature increases, the rate constant K will also increase. Okay, and then if the activation energy decreases, K pun akan increase juga. Okay, so temperature dengan K, they are directly proportional, tapi activation energy dengan K, they are inversely proportional. Okay, so the lower the K, the lower the activation energy, the higher the K then. Okay, so activation energy is influenced by the catalyst. So addition of catalyst will provide an alternative pathway with lower activation energy and thus increasing the value K. Sebab kalau activation energy tinggi, so susah kita punya molekul nak lalu yang ni kan. Okay, so less molecule mungkin yang akan dapat react compared to kalau a lower activation energy, more molecule boleh react. Okay, so EA dengan K inversely proportional. Okay, kalau temperature dengan K directly proportional. So graph representation, so kalau kita nak kena plot graph daripada yang the linear equation tu tadi, so dia akan jadi ln K versus 1/T dan okay, so ada y equals to mx plus c. So kita punya y axis adalah ln K, x axis kita adalah 1/T. Okay, and then you will get a linear graph whereby dekat bahagian intercept tu nanti itu adalah ln A. Okay, yang slope tu pula, which is the gradient, itu adalah negative EA over R. Okay, so ini adalah bahagian intercept. Ini kalau kamu kira dia punya gradient ni, kamu akan dapat negative EA over R. Okay, so if a same reaction conducted at two different temperature, T1 and T2, okay, so now kita akan tengok pula what happened to, macam mana kita nak guna Arrhenius equation ni tadi untuk kira if ada dekat dua temperature yang berbeza. Because you have to know that once temperature berubah, the value of K akan berubah juga. Okay, tapi activation energy dia sama lah. Okay, activation energy dia sama. Tapi kalau kita ubah temperature, K akan berubah juga. So ln K, banyak betul hilang the sign. Okay, so ln K tambah kat sini. So kita ada dua condition kat sini. Okay, so ini adalah untuk condition 1. Okay, temperature 1. So satu lagi adalah untuk temperature 2. Okay, so kita ada dua kat sini. So rearranging this equation, kita akan dapat ln K, I think in 1 second sini plus equals to ln A. Okay, and then yang ni pun plus equals to ln A. Okay, so bila jadi macam ni, we can see that since A is a constant, kan? So ln K plus EA over R 1/T1 is equals to ln K2 plus EA over R 1/T2. So bila kita rearrange balik juga benda ni, so apa yang kamu akan dapat adalah ln K1 minus ln K2 equals to EAR 1/T2 minus EAR 1/T1. Okay, oh banyaknya equation kan. Okay, tapi the final part ni, ini yang paling penting sebenarnya. Ini je yang kamu kena tahu sebenarnya. So basically daripada yang ni tadi, yang bawah sekali ni tadi kan, so kita boleh simplifykan. Dia boleh jadi ln K1 over K2 is equals to EA over R. So kita bawa keluar EA over R, since dua-dua dekat this side ada EA over R, dan ni pun ada EA over R, so kita factorize bawa keluar, so dia akan jadi 1/T2 minus 1/T1. So this is the equation yang kamu akan guna if given to you ada dua temperature and you have to look for the new K value. Okay, but sometimes you are given both temperature, you are given both rate constant, and then you have to look for the activation energy. Boleh juga. Or maybe dia bagi kat kamu rate constant, dua-dua rate constant dia bagi, okay, and then activation energy dia bagi, temperature pula dia bagi satu je. So you have to look for another temperature. This particular equation here, dia boleh play around lah, sama ada nak kamu cari temperature, dia nak kamu cari activation energy, ataupun dia nak kamu cari rate constant. Okay, so example 1. So kita ada decomposition of hydrogen iodide kat sini. So it has a rate constant of 9.51 exponent negative 9 liter per mole per second. Okay, at 500 K, and 1.1 exponent negative 5 liter per mole per second at 600 K. So find EA. So apa yang kamu kena buat sekarang adalah keluarkan dulu info yang ada. So rate constant 9.51 tu dekat 500 K. So let's say kita anggap T1 500 K tu T1, T2 kita anggap 600 K. Okay, maksud the K1 rate constant kalau dekat temperature 1 tadi adalah 9.51 exponent negative 9, and then K2 pula adalah 1.1 exponent negative 5. Okay, and you are asked to look for EA. So by using the Arrhenius equation yang last kali tadi yang kita buat tadi, okay, you can find the AA. Okay, so kita masukkan je dalam formula tu. Okay, so sebenarnya it doesn't really matter if lah kamu identify that the T1 adalah 600k, the T2 adalah 500k, it doesn't really matter. Either way, you still get the same answer. Okay, you still get the same value untuk EA. So masukkan je value into the formula. Okay, and then just use your calculator lah. Okay, just use your mathematics skills untuk transfer all the numbers. Okay, and then you can get 1.76 exponent 5J per mole. Okay, tapi ni baru J per mole. So let's say soalan tak ada minta specific the activation energy in kJ per mole, so you can leave your answer like this, in J per mole. However, if specifically dia minta dalam bentuk kJ per mole, then you have to change lah. Okay, so write down 176 kilojoule per mole then. Okay, so ni example 1. Yang ni just kita guna formula yang ni tadi. Okay, kita guna pakai this particular formula. So this is one way of solving nak cari K kah, nak cari T kah, ataupun nak cari A by using calculation method. Okay, ada satu lagi adalah kalau kita guna graph method. Okay, so if kita guna graph method, kita bukanlah guna yang K1 ln K1 over K2 tu tadi tak. Okay, yang ni kita just guna yang ln K equals to negative EA over R 1 over T plus ln A. Ini kita akan guna yang ni. Okay, so the table below shows the value of rate constant for the composition of halogen iodide. So using the data below, plot ln K versus 1 over temperature and determine the activation energy for direction. So you have to determine the activation energy. Given data to you is only K dengan temperature je. Rate constant dengan temperature je. Tapi you have to plot ln K dengan 1 over T. So kamu kena buat another set of data kan, another set of table yang ada ln K dengan 1 over T. So ni Miss dah buat siap-siap lah untuk kamu kat sini. Okay, so kalau this is just example on how to solve soalan yang involve graph. Okay, so daripada yang second table ni tadi, so boleh dah plot graph, so dapat something like this. So you should be able to get a linear graph. Okay, and then daripada linear graph yang kamu dah plot tu, you can find the gradient. Okay, so find the gradient. So kat sini dia tolong kirakan dah. Okay, so you can get negative 2.24 exponent 4k. Okay, jadi kita kena take note that kenapa K kat sini? K ni adalah untuk 1 over T ni per 1 over T adalah per Kelvin, right? Ln K tak ada unit. Okay, and then so since ni adalah per Kelvin, so since dia kat bawah nanti dia naik atas balik, so dia jadi K. Okay, so daripada value M ni tadi, so this is kita punya value M, which is kita punya M ni tadi adalah negative EA over R. Okay, so now you can solve your activation energy. So R nak dapat daripada mana? You can get from the list of constant, which is 8.314. Make sure you be careful with the unit. Okay, so masukkan values inside, and then you will get the activation energy adalah equals to 1.9 exponent 5J per mole. So depends on soalan. Miss tak ingat soalan tadi dia minta tak dalam kJ per mole. Kalau dia minta kJ per mole, bagi jawapan dalam kJ per mole. Okay, 190 kJ per mole, then the answer for this. Okay, so it's time for you to try. Okay, to try this 1.0, and then you can try this 2.0. Answers has been given to you. Untuk try this 3.0, okay, Miss baru sedar you can only answer question 1 and question 2, and it doesn't dia tak ada kaitan pun dengan this particular subtopic sebenarnya. Okay, so it was actually from the subtopic 1.1, and then 3 pula tak boleh nak jawab lagi sebab kita tak habis lagi 1.1. Okay, so it's okay untuk kamu abaikan the try this 3.0. You can try this later on bila-bila. Okay, yang penting adalah try this 1.0 and 2.0. Yep, that's it. Bye.